All right, so in this next section, 3.4, we're going to talk about function operations and compositions of functions. So in short, in terms of operations on functions, our four basic operations, addition, subtraction, multiplication, and division, can all be performed on a function. When we do those operations, so you can see it written a couple of different ways. So you can see it written as f plus g of x, or f of x plus g of x. They're 100% equivalent. A lot of times I will break it apart into the f of x plus g of x, or f of x minus g of x form, just because I think it helps students visualize better what's happening. Okay, a couple things to note when we're doing this. For addition, you just add, you combine like terms. For subtraction though, you are subtracting the entire function, in this case g of x. Make sure you put parentheses around that entire function g of x. That way you distribute a negative to all of the terms, so that you end up with the proper answer. When you are multiplying, it's this entire function times this entire function. And again, we need parentheses here so that we distribute appropriately. All right? In each of the first three cases, the domain of the function operation is going to be the intersection of the individual domains f and g. Okay, so wherever those domains, individual domains overlap. Okay, value has to be in both domains to be in the domain of the operations function. All right. When we get to f of x divided by g of x, it's still going to be the intersection of the domains. However, we also must consider the fact that my denominator cannot equal 0. Okay. The other thing that's really important is we can't reduce or cancel in the f of x divided by g of x unless they are both completely factored and have a common factor. So don't just cancel off an x squared term or something like that. If it's in standard form, we're not allowed to do that. Remember, it must be factored completely. Composition of functions is typically written with the f in the open circle, so f of g of x, which is how it's read. So you can have it f of g of x, as written here, or I typically rewrite this, and let me exaggerate it a little bit, f of g of x. And I'll even write it with the parentheses slightly different size so I know which function is being put into the other. So this is really f composed of the function g of x. So what does that mean? So I'm going to take my function f of x, and anywhere that I have an x in that function f, instead of replacing a value, like if I had f of 2, I would plug in a 2 everywhere. Now, instead of plugging in a number, I'm going to plug the entire function g of x in everywhere I have an x in the function f. Right? Again, make sure you have parentheses around that entire function g. You may have to distribute. You may have to raise something to a power. You're going to have operations that have to be performed on the entire function. So in terms of domain and range, the domain of f of g is a set of all x in the domain of g, such that g of x is in the domain of f. So what in the world does that mean? Right? Essentially, we're going to have some set of x values that gives me the range for g of x. And in the range of g of x is going to be the domain of f of x with any possible restrictions being removed. Okay? We're really not going to look a whole lot at the domain and the range. At that stage, look at the actual composite function itself and see if that composite function has a domain restriction. The only other thing would be to also take a look and make sure that g of x didn't have any domain restrictions going in, right? So let's go through, let's do one or two here. So I have f of x equals 3x minus 2 and g of x equals x squared plus 2x. So if I have a function f plus g of x, again, remember this is f of x plus g of x. So here I'm going to have 3x minus 2 plus x squared plus 2x. Right, here's my function f, here's my function g. Now I'm simply going to combine like terms. When I combine like terms here, I'm going to get x squared plus 5x and minus 2. This is f plus g of x. in f minus g, right? Again, we're going to have f of x minus g of x. And I'm putting entire g of x in parentheses. So again, here we're going to have 3x minus 2 and minus x squared plus 2x. When I distribute that negative, we have 3x minus 2 minus x squared minus 2x. And we're going to get negative x squared plus x minus 2 for f minus g of x. F times g of x. We're going to remember f of x times g of x. Right? So here we're going to have 3x minus 2 times x squared plus 2x. When I distribute, I'm going to have 3x cubed plus 6x squared minus 2x squared minus 4x. Combine like terms, we're going to have 3x cubed plus 4x squared minus 4x. This is f times g of x. In f divided by g of x, we're going to again have f of x over g of x, which is going to give me 3x minus 2 over x squared plus 2x. Now, here there's nothing that we can reduce. It is not in factored form. However, if I were to solve my denominator, I would get that x cannot equal negative 2 and 0. And I'm going to list them as restrictions. So I'm just going to put a semicolon there, and then x cannot equal, and I'm going to list out the restrictions, just to simplify things for right now. So I have a question that we typically talk a little bit about. It is, does f of g of x equal g of f of x? Does that always work? I mean, sure, there's probably some cases where it works. Does it work all the time? So we need to think about that for a second. Even maybe pause the video, try and come up with an answer in one way or another before going on to the actual next question. So we're going to test it out. So here I've got f of g of x, and I've got g of f of x. So I want to find the actual composition of functions. So here we're going to have f composed of g of x, and then in the second we're going to have g composed of f of x. So f composed of g of x. I'm going to show the actual substitution here in 2 steps. So here I'm really going to have 3 times my entire function g of x minus 2. So when I actually do the substitution, you can skip this step here. You don't really need to show that. All right, I'm going to have 3 times the entire function x squared plus 2x and minus 2. So here when I distribute, I'm 3x squared plus 6x minus 2. Okay. In g of f of x, so here we're going to have the entire function f of x squared plus 2 times the entire function f of x. So when I substitute in, we're going to have 3x minus 2 squared plus 2 times 3x minus 2. Remember that when I have 3x minus 2 all squared, it's 3x minus 2 times 3x minus 2. All right, so when we FOIL here, and I'm going to FOIL and combine like terms all at once, we're going to have 9x squared, we're going to minus 6x or minus 12x and plus 4, and then we're going to have plus 6x and minus 4. So we combine like terms, and we have 9x squared minus 6x, and 4 minus 4 is going to be 0. So here I have g of f of x, and here I have f of g of x. They do not equal. So in general, f of g of x is not going to equal g of f of x. There are some special cases where this is going to happen, but it's not going to happen in general, and we're going to talk later in the unit about when that happens and what that means. So I've got a couple here, and there are a few others that are in here where I want you guys to evaluate and find a couple of different things. I'll go through and do 1 or 2 of these here. If we're actually evaluating at using a certain value, it's easier a lot of times to evaluate each individual function, get a simplified result, and then add, subtract, multiply, whatever those results are. So if I had f of -3 here, we're going to have square root of 2 times -3 squared minus -3, and then minus the entire function g. So we're going to have 4 times -3 minus 1. So when I simplify, here we're going to have 9, 18 plus 3, or we're going to have square root of 21. And we're going to have minus -7 minus 1. So we're going to have minus -8 or plus 8. There's nothing that I can simplify there. So that's actually going to be my simplified. When we have composition, think about order operations. You're going to work inside out, right? So I'm going to find g of 2. And whatever g of 2 happens to equal, then it's going to give me some number. I don't know what that number is yet, but then what I'm going to do is evaluate f of that value, okay? Because I'm going to replace g of 2 with its actual solution. So here, g of 2, we're going to have 4 times 2 minus 1, or g of 2 is going to equal 7. So I'm going to take this statement of equality, and I'm going to replace the g of 2 in f. So instead of f of g of 2, I'm going to have f of 7, because g of 2 equals 7. So now I'm going to evaluate f of 7, which is going to be square root of 2 times 7 squared minus 7. So here we're going to get 7 squared is 49 times 2 is 98, minus 7 is going to give us 91, so we're going to square root of 91. Right? There's no perfect square factors within the square root of 91. So f of g of 2 is going to equal the square root of 91. Right? I do also in here have a little graph shifting review. I want you guys to give these a try. We'll take a look and talk about them when we get into class tomorrow. All right? Have a good night.